the Kalahari Desert, Namibia. I'm here to find an extraordinary ancient tribe of people, the San Bushmen. Our research shows that their distant relatives left Africa and set in motion the family tree of mankind. From them stemmed every color, creed, and nationality alive today. We know the fathers of mankind started their journey from here, but why did they leave? I'm hoping the few survivors they left behind, the San Bushmen, will help me solve this fundamental question.
So
50,000 years on, I hear their numbers are dwindling fast. Soon they could be gone entirely. I'm arriving not a moment too soon.
Hello? How are you? I'm Spencer.
And my two children, they are boys. This is my wife.
Amazing. Do you want to see a picture of my daughter? This is her in her school uniform. What's her name? Margot.
I have to explain to them why I'm here. But how do I begin? For a start, what's Bushman for geneticist anyway? I sense this is really going to be tough for a lab rat like me.
I just want to tell you a little bit about why I've come here. It's mostly to find out about your way of life. I'm really excited to be here. You know, it's such a dream for me to get to meet the San people, the Bushmen. In a way, you carry a secret in your blood, and you can think about it like a family tree.
I explained the tree was just like the family that we all belong to. My family line is one of the small fractured branches at the very top, while theirs is the oldest on Earth, the biggest branch at the base of the trunk. I get the feeling I'm not explaining this at all well, but they're way too polite to say so. This is really quite embarrassing.
So it's a great privilege for me to come and meet my distant relatives and the people who give us a glimpse of all of our ancestors. So in one sense, we're all Khoisan. We're all San people. It's just that my skin is slightly redder.
We would like to thank you for the information that you brought for us.
This is like a dream for me. Everything predicted in their blood seems to be written in their faces. It's like looking at a composite model of every face from around the world. The eye shape of East Asians, the high cheekbones of Mongolians, the mid-brown skin that could turn darker or lighter. So how do I know that of all the people on Earth, the San are direct descendants of our oldest ancestors? I'll try to explain a little better this time. I work with DNA, our very own manual of life. It's in our blood, in every cell of our body, orchestrating our life processes. DNA is a ladder of just 4 linked molecules, A, C, G, and T, strung together in pairs in an incredibly long and complex sequence. If laid out, the DNA from one person would stretch to the moon and back 3,000 times. In our cells, this chain is broken into 46 bundles called chromosomes. Because of its sheer length, DNA is prone to develop small glitches in its sequence. They're called mutations. Everybody has them. When they occur, we pass them on to our children. We call these inherited mutations markers. As our chromosomes pass down through the generations, they carry these markers with them. They write our history. They are the source of our time machine, the way we can see back to our earliest ancestors. The markers I follow are found only in men, on their Y chromosome, the chromosome that makes men men. But of course, men don't travel alone, and the journey of man is the journey of everyone.
I was walking through the village and I saw that they had massive piles of these sitting around everywhere. We call them monkey oranges. And they taste pretty